I said earlier in the co-rec, you got to keep an eye on the screen. Just glance at it, make sure it's focused, because I never look at it. And if it's not in focus, then recording and sending you guys recordings doesn't really do any good. You could always click on Tuesday, Thursdays and maybe it's better. Okay, so keep an eye. Another thing, I get a lot of emails about, when is this going to happen? When is that going to happen? What day? What this? I go over at the beginning of every YouTube, the calendar over here, see where I stand? So I don't have to reply to those emails. I don't, type it. I never feel, I'm very, insecure about my writing. So whenever I feel like I'm writing something, I'm answering one of your questions about something, I don't want to sound like I'm being sarcastic or anything, because in my mind, I think I am. So I don't want that to come out. But I also want to make sure I say it in a way that you understand what I'm saying. And I never know, because people don't answer what I just wrote. So I'm like, well, it's yours. I don't know. So I put it at the beginning of every YouTube, and it's like, here we go. Review. Homework is due on Wednesday. Chapter 3-4 test is Wednesday. That's the last day we meet as a class, for class. And then the final is Monday. It starts at 10. We're not turning anything in, so it starts at 10. Try to be early. Be here by 10:10. That's the wrong way. 9:50. Okay? Until 10. It ends at 11:50. It's an hour, 50 minutes. You need a Scantron 882-E, number 2 pencil. I'll provide scratch paper. The last class meeting for math for the co-rec is this Wednesday the 4th. We don't meet during finals week. During finals week, it's just an extended office hour from 7:30, usual office hour time, until 9:30. Office hour is going to end at 9:30 because I want to make sure everything is ready for the final. I usually write up a whole bunch of stuff like, how do I get my grade? You can email me, which, as long as you don't do it through Canvas, I will send you a PDF of your overall grade. When? Not until after the following Monday. Any emails before that Monday, I throw them in the trash can. Okay, because I'm not going to respond to it. It's just going to get lost. It's going to sit there, and I'm not going to respond to them until I actually post my grades by the Monday. That's the 9th. So the 16th is when my grades due at noon on the 16th. So I want to make sure everything is finalized before I send you what your grades going to be. Okay. So I always say Monday, and I'll put it on the board, Monday, the 16th at 3 p.m. Then I will reply to whatever you say. Okay. So let's talk about the chapter 3-4 review versus the chapter 3-4 test. So here's the setup. It's a little bit all over the place. It will, because it's not going to be, it's not as traditional as your review sheet was in the past. It's a lot more stuff, a lot more examples. So directions. Make sure you read file directions. Simplify, reduce answers to lowest terms when you have to give an exact value. Decimal answers, one of the directions. Say so, round appropriate. Solutions in the space one is provided. You have to show appropriate work with equal credit as usual. Correct answers on that. Work has support your answer. Make sure you do a pencil. Don't screw up. Always, raise, be neat, legible, no scratch paper as usual. It's 176 points. 22 questions. 8 points. Okay. 8 bonus questions of 4 points apiece, or 5 points apiece. So that's 40 points. 40 plus 176 would be 216 out of 176 if you aced everything. Here's how they compare. It's going to be a little different. First of all, As you can see over there, and I can't put both on the same screen, so sorry. What if I do this one? That's a little bit. The first two questions use long division, so you're told what method to use. So on the review sheet, 1, 2, 3, you're going to have two of those. And then on question 4 and 5, you use synthetic division, you're going to have two of those. Now, in these division questions, you're going to have what I basically one nice one and one fix it first. So that means one nice one, all the powers are there and it's in the right order. You don't have to think twice about it. It's all organized correctly. The fix it first, maybe it won't be both. Maybe it's missing a power, so you got to use a placeholder, or maybe it's scrambled, so you got to put it in the correct order. But it won't be both of those things. Okay. Any questions there? Okay. Then numbers 6 through 10. Then the next three questions, approximate the number using a calculator, round to your answer to 4 decimal places. 4 decimal places. So you're going to have two of those. Make sure you have a calculator, and if it's battery powered, make sure you have a batteries, extra batteries, check your batteries. Okay. Now this is where it gets a little nuts, because this is where it goes all over the place. On the review sheet, numbers 11 through 15. 26 through 30, 45 through 50. Those are solve the equation. You're going to have a total of 3. Okay, for your solver. Number 23 through 25. You're going to have 1. Sorry, 2. You're going to have 2 of those. Write it in logarithm form. So right there, 12 and 13, write as a logarithm. Actually, I missed one. And that doesn't matter if you put it out of order, but numbers 16 through 18, I knew I missed it. I know that I look at it at the very bottom. 16 through 18, you're going to have 2 of those as well. And that's where you put it in exponential form. So you're given a logarithm, base to the across equals what's inside, put it as an exponent. Here you're given a logarithm, you want to put it back as an exponent. Just like the number 2 and number 3 on the quiz. Then number 31 and 32. Rules of logarithms, you're going to have one of those, multiple choice, just like the review sheet. And 33, 34, one like that, multiple choice. So the rules of expo or rules of logarithms, you're going to have multiple choice questions. 35 through 40, three of those. Forty-one to 44, two of those. It should be 22, so 4, 6, 9, 9, 11, 13, 14, 15. That's 20.
19 through 22.
Yeah, 19 through 22.
I think that's the only one.
What am I missing? 7,
Collins evaluates a lot.
yeah. But that is going to be evaluate the logarithm. Number 7, 8, 9. And that's basically where it says decimal places though. So that's going to kind of fall into well, 6, 8. That's copy. One, 2, Well, here's again, I guess that's where that, yeah, you are at 19 through, what is it, 19 through 22?
Yes.
So 19 through 22 falls in here. And that is going to be a pocket. That's 22. So that's 22. Now, two of them, actually, three of those in that set, I like them as bonus numbers 11, A potential bonus. Yep. No, 11, I like is a bonus, and 14 and 15. Also on our bonus list would be over on the bonus list. If you look right here, you have omega of x equals blank, and oh my gosh, why am I blanking? I shouldn't be blanking on this. Gamma of x equal f of x equals blank, and psi of x equals blank. Evaluate something, circle something of x. And then again, so a couple of function notations, which you're going to have to be able to do on the final. Now, I promise not to use Greek, but I just want to set it up differently. Solve using completing the square or the quadratic formula method. So you pick, but you have to solve it one of those ways. Solve using any algebraic method, but you have to show the work to get there. And then here is a couple of extra problems like I was talking about, maybe one of these type or something else. Okay. And then a long division where it probably is going to be scrambled and missing a power. And then a synthetic division where it's going to be scrambled and missing a power. So 8 bonus questions, 5 points apiece. 217, 216 out of 176. A lot of these questions, as I told you, they go by very quick. You manage your time right, and you have practice, they can go by very quickly. Make the most of it. This test can be so in the co-rec this morning, we did these 5 from the review. I don't mind doing them again if you want to see them. So you can always do something else. You can ask questions from the final focus if you looked at that. I don't mind, whatever you ask. These are the problems we've already done as examples in class. Those are the ones that are on YouTube. I sent you the email. I put up an announcement, but links to the 3 separate YouTubes from 2022. So you have a lot of examples from 4.2 to 4.3, 4.2 to 4.4. 3.3, there's a lot of examples, or a few examples. We've done some more in class. What do you want to see?
Number 17 on the review.
17 on the review. Okay. Write an equivalent expression in exponential form. So we just got to convert that to the next one. On base 16 of 2 equals 1/4. So base to the across equals what inside. What's the base of the logarithm? So base 16, base to the across, 16 to the 1/4 power equals what's inside. Base to the across equals what's inside. 17.
That's number 5 on the review.
Number 5 on the review. X to the fifth plus X to the third plus 1. And we're using synthetic division, dividing by X plus 3. So if this was your more challenging one on the test, is it missing the power or is it scrambled? Missing the power. Missing 1 or missing 2? Okay, missing 2, missing 3. Missing 3 powers. Missing 3 exponents. So before you even think about starting, rewrite it. We should have X to the fifth. We need, if they have an X to the fifth, we need an X to the fourth. So 0, X to the fourth. We have an X to the third. And then it stops at 1, so we need an X squared. So 0x squared. A 0x to the first. And then the 1 divided by X plus 3. So my placeholders, 0x to the fourth. 0x squared. And 0x. That way, everything lines up where it's supposed to. Now, we're told to use synthetic division to identify what is K equal here. -3 is the opposite sign. X minus K, so K is a -3. So the first thing we do now is we draw the box. And we put K in the box, K is a -3. And then we make a list of the dividends coefficients. What's the coefficient here? 1. How many X to the fifth? We have 1 X to the fifth. So we have a 1 X to the fifth. And then we have 0 X to the fourth. And then we have a 1 X to the third. And then we have 0 X to the second. And then 0 X to the first. And then we have a 1. All the terms should be represented. X to the fifth, X to the fourth, X to the third, X to the second, X to the first, X to the 0 for the constant. And then we draw a line down here, leaving some room because we're gonna do some stuff in here. Here we go. The rest of it is bring this first one down, bring down the 1. Now you multiply and then you add. Then you multiply, then you add. So bring down the very first term, and I would take 1 times that -3, and we get -3, and then we add. 0 plus -3 is -3. Then we multiply. This -3 times that -3, that's +9. Then we add. 1 plus 9 is 10. And then we multiply 10 times that -3, that's -30. And then we add 0 plus -30 is -30. And then we multiply -30 times -3 is +90. And 0 plus 90 is 90. And then we multiply 90 times -3. Is -270. And then we add, and that's -269. That last number is the remainder. So the answer, the quotient, these are the coefficients of the quotient. The quotient is going to begin 1 degree less than the dividend was, because if you look at it, we took an X to the fifth polynomial, X to the fifth power, we divided by an X to the first. We took an X to the fifth, we divided by an X to the first. What power would the answer start with?
X to the fourth.
An X to the fourth. So it's going to be 1 times X to the fourth. Now, I'm gonna write this out, and this is gonna be losing points if I leave it. But just so you can see it, it would be a 1 times x to the fourth minus 3 times, just start decreasing. This would be 3 times x to the third plus positive 10x to the second minus 30x to the first, and that would just be a plus 90. And then you have a remainder, so plus negative 269 over the original divisor, x plus 3. But if I leave 1x to the fourth, that's not simplified. 1x to the fourth is just x to the fourth. So don't leave the 1. But I know a lot of people, they see it, so they want to put it. But 1 times 5 is just 5. You wouldn't leave it. And that's our synthetic division. Number 5, what else?
Yeah, number 2 on the
Number 2?
yes.
Okay. Two is 6x squared plus 17x minus 45. That is divided by, bless you, 3x minus 5. So, are there any powers missing? Is anything out of order? Nope. Everything's ready to go. And then over here, no powers missing. It's in order as well. So it's going to be, when it's long division, the divisor's on the outside, the dividend goes underneath. So 3x minus 5. And underneath is 6x squared plus 17x minus 45. We do long division. All you care about, the only thing you look at, what times 3x is going to give us 6x squared? What times this 3x is going to make what's inside the dividend 6 times x to the second? We have a 3, we want 6. So what times 3 is a 6? We're going to need a 2. I have x to the first. I want x squared. So what do I need here? X to the first. 2x times 3x is 6x to the second. That's going to give me the 6x squared that I want. So that's going to be the first term of the quotient. It's an x to the first. And that's why we want to make sure we write it nice and neatly. Because it's about place value. You have 3 choices of where you're going to put this part of the quotient. Above the x squared. Well, if you put something above the x squared, it should have an x squared. If you use an x squared, that would give an x to the third. I don't have any x to the thirds. So you shouldn't be starting with the x squared. You're not going to have anything. X to the first, 2x. That's why we're starting here, which is going to help you realize I only have to go one more place up. I'm almost done. When you pick this first term, remember you have to distribute. Once you pick the 2x, you're going to multiply times the divisor, 3x minus 5. You don't have to show it over here. If you understand, you're going to be able to go 2x times 3x. Well, that's why we chose it, 6x squared. 2x times negative 5 is negative 10x. And you can just distribute, just like I did. If you need to see it, then do it over here on the side. 2x times 3x is my 6x to the second. Positive times a negative is a negative. 2x times 5 10x. That's the next line. The next step with long division is we subtract. This better cancel out. It better make a 0. 6x squared minus 6x squared is 0. But the reason why we subtract each one is so you can see right here, subtracting the negative means we end up adding. We end up getting positive. 17x plus 10x, that's 27x. And then you bring this minus 45 down. And just like long division, then you go again, go to the next place value. The next place value is the constants. And so we only look at the first term, 27x. And you only look at this first term, 3x. And what times 3x gives me 27? I need 27. So what are we going to multiply by? 9. And then I need an x, but I already have it. So the only thing I'm going to multiply by is a 9. And it's going to be a positive 9. 1 times 3x is 27x, 9 times 3. So now you distribute. 9 times that 3x gives me the 27x. And then 9 times negative 5 is going to be a negative 5. 9 times the divisor, 3x minus 5. 27x, negative 45. And then you subtract. This better cancel, we get 0. Negative 45 minus a negative becomes negative 45 plus 45. 0. So it goes in evenly, and that's the only answer. You don't need to put plus 0 over the remainder, over the divisor. You don't put 0 remainder when you don't have one. Because it went in evenly. There's so many thoughts to say one at the same time as last one. 28. Well, we have let's move over there. 8 x equals log base 4 of 16, 4th root of 16. There's a couple of approaches for this. The first approach is properties of logarithms. 16 and 4. 16 is a power of 4. Log base b of b to the x. If the base of the logarithm is the same as the base of the exponential function inside, if the bases are the same, they undo each other, and you just get that x. I can rewrite 16 as a power of 4. It's also going to have to use rules of exponents. A to the m over n is the nth root of a to the m. If I have a radical, I can change it to an exponent. Because exponents and logarithms, they undo each other. So if you're determined, and this is where you kind of need to be if you keep on wanting to go on, is understanding the language. And also one more thing. If you don't like the way it's written, because usually we prefer log base 4, 4th root 16, and then equals x. You can flip it. So cheap. But this is log base 4. 4th root 16 is 4 squared. I'm just changing that 16 into 4 squared. So this is log base 4. A 4th root is a 1/4 power. Or let's do it this way. The radical, the root is a 4. The power inside is a 2. If I write it as a fraction, the power is the numerator, the radical, the root is the denominator. So this is a 4. To the 2/4. The numerator is the power to the 2/4. And I've been flapping my arms all semester long about simplifying fractions. What's 2/4? Mm-hmm. 1/2. This is log base 4 of 4 to the 1/2 power. So when the bases are the same, they undo each other, so the answer is just going to be 1/2. Now that requires a lot of manipulation and knowing your rules and exponent rules, logarithm rules, everything. But I told you at the beginning of this chapter 4 stuff. Base to the across equals what's inside is going to save your butt more than to the math. So that's all we got to do. Get rid of that logarithm. Base 4 to the across x equals what's inside the 4th root of 16. So now we're solving that. That's an exponential equation. So now what you have to do is rewrite it with the same base. So now it's a little easier to see than trying to use this rule and this rule combined. Because now we don't have a logarithm. You should know that this is a 4 squared. Because you're going to have base 4. So 4 to the x equals the 4th root, and that's 4 squared. You have to know that a 4th root is a 1/4 power. Those are the rules of exponents. The 9th rule of exponents. Number 9. A to the 1/n. So the numerator is just a 1. Is just the nth root of the base. Nth root of x. So it's a 1/4, it's a 4th root. So 4 to the x is 4 squared to the 1/4. And then a to the m to the n, power to a power, you multiply. 4 squared to the 1/4, that's 4 to the 2 times 1/4, or 2/4. 2/4 is 1/2. Since the bases are the same, this x has to equal that 1/2. Base to the across equals what's inside. So many ways to get there. If all you do is try to punch it into a calculator, you're not going to show me any work. If you use the change of base formula, log base 10 of 4 through 16 over log base 10 of 4, You're going to get 0.5 on a calculator, but what work are you going to show me? The whole point is to pay attention. Would I give you 15 like this? No. Would I give you 3 like this? No. Would I give you 2 like this? No. One maybe. One maybe. What else? 15. We did 15. Let me see. Yeah, 15 is not too bad. It goes on the same line. We need a common base. Same base on both sides, the powers equal each other. So it's set up perfectly for you to recognize the fact that the only base you're going to be able to rewrite it with is E. You got an E on this side, E to the x minus 3. You got E on this side, E to a 6. But one E is in the numerator, one E is in the denominator. That doesn't work. If something's in the denominator, you can flip it up. And not that when I say rule number 8 of exponent, it doesn't matter what number it is. I'm just giving you context. Rule number 8 of exponents, a to the negative m. If it's negative in the numerator, you can flip it down. It's 1 over a to the positive m in the denominator. Or if you have a negative in the denominator, you can flip it up and it's positive in the numerator. But equals goes in both directions. If I have a positive in the denominator, I can still flip it up. I can go this way, but I just have to make it negative. I want E to be either both in a denominator or both in a numerator. You're going to be better off if you put both in the numerator. So this would be E to the x minus 3 equals, parentheses still, this is now E to the negative 6 to the x plus 3. Because now you have E as a base on both sides. We got to do one more tiny little thing to it before we finish it. Before we actually finish it. Go to start solving. Rule number 2 exponent is actually this one. Power to a power. When you have power to a power, you multiply. So this is going to be E to the x minus 3, and over here it's going to be E to the, since it's 2 terms, it would be negative 6 times x plus 3. When I was grading your quizzes, some of you were struggling with your own handwriting in terms of, did I just write down an exponent because it didn't look like it? And so you weren't doing what needed to be done, and you kind of wrote a different question than what on the board. you ever have any questions about what it is you're working with, ask. Don't assume. Since you now have the same base, either this equals either that, you can just take this exponent, x minus 3, has to equal that exponent, negative 6 times x plus 3. Since the bases are the same, the powers have to be equal. I'm just solving a linear equation. Simplify both sides before you go on first. This side is simplified. Over here, distribute the negative 6. Negative 6 times x. Negative 6 times 3. Minus 18. And then figure out, are we going to take the x's over to the left? We're going to subtract x from both sides, or we're going to add 6x on the side. So we're going to go left, we're going to bring right. So add 6x to the side. Bring over here to the left. So that gives us 7x minus 3 still. And over there we have negative 18. And since we've got the x's to the left, we're going to take this negative 3 over to the right, add 3. 7x equals negative 15. And then you divide both sides by 7. X equals negative 15. And divide by 7. And x equals negative 15 over 7. $31 and $34. Those are multiple choice. The best thing you can do is process of elimination. May not remember the rule exactly as it's stated. So trying to work it out, you don't have to, you're not going to show any work. You wouldn't be showing any work when you do this on your test because it's multiple choice. On the test, it's going to say write the letter, or no, because the choices will be right here below it. You're just going to circle the letter of your choice. So it's going to list all the choices just like it does here, and you're going to circle the letter of your choice. And you don't need to circle the whole thing because it just gets you. So log base A of 8 times x to the 5th times y, multiplication. We know we have some kind of property that simplifies multiplication into something else. Usually takes an operation down one level of difficulty. Multiplication becomes what? Addition. There's that connection, addition. And it's that rule of exponents it's connected to is the very first rule. A to the m times a to the n. When you have multiplication, you add the exponents. Logarithms and exponents are connected. Multiplication becomes addition. So there's two here with addition. First of all, it should not look anything like the log base A of these three things multiplied together. It's just the logs multiplied together. When did we ever do that? And in addition to that,
no pun intended, where'd the 5 go? Because there's no 5 there. So that's out. It can't be. And then log base A of 8 times x to the 5th times y is now just 8 plus x to the 5th times y still in the logarithm. Now, so log base 3 of 5 is just log base 3 of 2 plus 3. That doesn't make any sense. Log base 3 of 5 times 9 is the same as log base 3 of 5 plus 9. So log base 3 of 45 is the same as log base 3 of 14. No. That doesn't look anything close. So these two. And the only difference, that's the same thing. Log base A of what? The only thing that's different is the middle term. And what's different is parentheses around the whole logarithm to the 5th, or 5 times it. Now, there was that little something about Price is Right, where a 5 came down, or a power came down at front time. So here's the question. Is the entire logarithm going to be raised to the 5th power? If it's only x to the 5th, would we raise the whole logarithm to the 5th?
No.
No. It's x to the 5th. You would end up separating these two like you have here. So you would have a log base A of x to the 5th, not the whole thing to the 5th. And then the Price is Right, come on down, you'd have this. So one of these things ain't like the other. And you can eliminate without actually trying to do that problem. Okay. Same thing on your final. Final's multiple choice. So look at the final focus and try to eliminate answers and figure out which one is a better choice, not just guess randomly. You can do a lot of the final without actually doing the entire problem. But you got to practice it before you actually show up on Monday. So,
43.
43. So now we're round to the nearest thousand. We're solving and the reason why is because on the left side you have an E, but on the right side we can't get a base E. Same thing with 42. This is 3 to the 4x minus 3. It's not times because we're dealing with exponential. The whole chapter 3 and 4 is about solving exponential problems. I know it looks like 3 times, but it's got a little bit of a lift to it. So if there's ever a question, make sure you ask. So you can't get base E on both sides. So we're going to end up doing logarithm. So write that down. And we leave it on. And it's going to be a calculator. You have to do first is if I'm going to take the logarithm of both sides, I don't want to take the logarithm until I just have E by itself. Just like if I was solving this problem. Let's say you were solving 5x squared is equal to, let's just go with 10. If I'm solving this, I have a nice perfect square. You don't take the square root right now, because now on this side you have x square root 5. if you simplify correctly. You have a square root of a 5, and then the square root of x squared is an x. And then over here you got plus or minus square root of 10. What you need to do is isolate your perfect square. Divide by 5 first. You have a nice x squared equal to 2. Now take the square root of both sides. So if I'm going to use a logarithm to undo this exponential base, what should I do first? So get this e to the 6x plus 9 by itself. So what would I do?
Divided by 3.
Divide both sides by 3. 3 times e to the 6x plus 9. So I'm just going to divide both sides by 3. So e to the 6x plus 9 is equal to 5 over 3. I cannot write both sides as a base e, but I can undo this by taking a logarithm of both sides. Since it's base e, which logarithm should I use?
Natural log.
The natural log. When I take the natural log of both sides. All right. For 1 billion points, not to be redeemed this year. What is the natural log of e to the 6x plus 9? 6x plus 9. Good. Because of, is it still there? This rule. If you have log base b and then inside is an exponent base b. If the bases are the same, they undo each other. You just get the power. So when you have natural log of an e to the x, so the base of the natural log, we don't write an e, but there's an e down here. And then inside you have an exponent base e. So that's a base e, that's a base e. They undo each other and you just get the, whatever that power is. So this logarithm is base e. Inside you have an exponent base e. So this natural log undoes this natural base, and you just get the power. You get the 6x plus 9. That's the whole point of taking the natural log. And over here, let's just change it to a decimal. Let's go ahead and take the natural log of 5 over 3. And don't round until the very end if you want to be accurate. Some of you are rounding so soon that you're not having accurate answers. So the natural log, and then 5 over 3, does it, equals. So this is 0.5108 256 238. And if you don't write out everything, okay, but make sure you use the entire decimal that's still in the calculator, because the next step would be subtract 9 from both sides. So you're going to have 6x equal to, you're showing me that work on your paper, and here you're just going to go minus 9. And this is now negative 8.489. 17436 376, and then you divide by 6. And x is equal to negative 1.414 862396. And then you round to 4 decimal places. 1, 2, 3, 4. That's 6 rounds to 8 up to a 9. So x equals negative 1.4149.
But as long as I have all the decimals in my calculator as I do the problem, I can round the answer from the calculator. What else? 39. So it says use the change of base. Fine to report it log. Base 3 of 93.73. So again, the calculator only going to do base 10 or it's going to do base E. So the change of base formula says we can change any base log base B of X can be changed into any base A, log base A of what's inside, divided by log base A of the old base. So since our calculator does base 10, we can take any logarithm base B of X and change it into the common log of what's inside, divided by the common log of the old base, or if you want to use the natural log base B of X can be rewritten as the natural log of what's inside, or the natural log of the old base. So just make a decision. Do we want to convert this into common log base 10 or natural log base 10? Which one? Base 10. So I would want to see this. I would want to see at least this is the common log of 93.73. And if you put a 10, that's all right. I don't have a problem with you putting a 10 over the common log of a 3. And now we're taking the common log of 93.73. And I'm going to write it out so you see how it works here. So the numerator is this decimal. That'll give me 1.9718786617 over common log of 3. Log of 3 is 0.4771212547. So then you divide. If you just want to type it in, then again, just be careful. Log 93.7. Close your parentheses, divide by the common log of 3. For 4.3128, round to the nearest or to 4 decimal places. So the 6 rounds that 8 up to a 9, 4.1329. Now, according to that, 3 of this power should give you 93.73. So if I go just to check it, and I go 3 to the, here's the exponent button, last answer, 93.73.
What's next? 37. 47. Solving. Log base 9, x minus 4. Plus log base 9 of x minus 4 equals 1. There is a nice little potential of this being, well, being a test question, but also on the other hand, being a bonus question, a little bit of one, half dozen of the other. Maybe 6 of one, half dozen. We've never solved anything that had 2 logarithms in a number. But we have the rules that allow us to make 2 logarithms 1 logarithm. And it's the 3rd page on the review sheet. And right here. 2 logarithms with addition in between. Can be put back together with what? Two logarithms that have addition were separated because it was what as one logarithm? Multiplication. So 2 logarithms came from 1 logarithm where it was multiplied on the inside. 1 logarithm. Okay. So when you look at this one, and you look at also in the same sense, number 46, 2 logarithms with addition in between. 48, 2 logarithms with subtraction in between. Number 49, 2 logarithms with subtraction in between. Okay, those are your keys. So I can put these 2 back together as one single logarithm, base 9, of this x minus 4 times this x minus 4 equals on that side 1. So this is base to the across, 9 to the first equals what's inside, which is technically x minus 4 squared. Which is my way of saying, hey, do you remember that you have a perfect square kind of number? You can take the square root of both sides. You get x minus 4 equals plus or minus 3. So that means when we add 4 to both sides, we have the potential of 2 answers. We have an x equal to 4 plus or minus 3. So we have an x equals 4 plus 3, x equals 4 minus 3. So if x equals 4 plus 3, the answer is 7. If x equals 4 minus 3, x equals 1. That doesn't mean it's both. You got to go back to the original problem's domain. If I plug in 7, 7 minus 4 is 3. I can take logarithms of a positive number. In terms of the rules of logarithms, log base b of x equals y, the rule was this. The base had to be bigger than 0. It also could not equal 1. What's inside? X had to be bigger than 0. You can't take the logarithm of a negative. You can't take the logarithm of a 0. So as long as that's okay right there, as long as it's not negative, as long as it's not 0, you're good to go. 7 minus 4, 7 minus 4, those are both positive 3. We're good. But if you plug in 1, 1 minus 4 is negative 3. 1 minus 4, that'd be a negative 3. Can't use it. So this one won't work. The only answer is 7. We have to make sure that we check because they both might work. They both might not work. One of them might work. But you have to get both to make sure. Okay, that's when we take square root of both sides, plus or minus. You have to solve one with the quadratic or solve with the quadratic formula or the completing the square method, and then you have one solve it any way you want. If you use the square root method, plus or minus, don't forget it. On the final, same thing, plus or minus, don't forget it. That's one. Three x to the third minus 112x. So if you have to do any rewriting, we do it now. X to the third, we're missing x to the second. So we're going to rewrite this. We have 3x to the third. We need 0x to the second. And then minus 112x plus 24. And then x minus. So it's missing a power. So the divisor is x minus 6. And the dividend is 3x to the third plus 0x to the second minus 112x plus 24. So what times x is going to give us 3x to the third?
No, 3 is
3x squared. I need 1x and 1 3, so 3. And then x to the third, I have x to the first, I need an x squared. So it's either going to start here. If it starts here, it would be an x to the third. X to the third times x is x to the fourth. I don't need an x to the fourth. So you go one place down you go. It would start with an x squared. X squared times x, that's an x to the third. So it's going to be here, and I need 3 of those x squared. 3x squared times x minus 6. So 3x to the third minus 18x squared. You subtract. 0, subtract the negative, make sure positive 18x squared minus 112x plus 24. And then you do it again. But you're only focusing on x and 18x to the second, and you're right here above the x to the first column. What times x is 18x to the second? 18x. So a positive 18x. 18x times that x minus 6. So there's that 18x to the second that we need. And then a positive times a negative is negative, and that's going to be 98. Sorry, 108. Eighteen x to the second minus 108x. And then subtract. Subtract each one. Careful with the signs. That cancels out. This becomes positive. Negative 112x plus 108 is negative 4x. And then a plus 24. We have positive x, we want negative 4 times what? What kind? Negative. We want a negative 4. Because we want a negative 4x, so we need to multiply by negative 4. So negative 4 times x minus 6. Again, you don't have to show the multiplication over here. You can just go negative 4 as long as you remember because it's true. Negative 4 times x, negative 4x. Negative 4 times negative 6, positive 24. As long as you remember, it's distribution. So now when you subtract, that becomes positive, so 0. 24 minus 24, that's a 0. So you don't write the remainder 0, it goes in even. Helps. 34. 34. Now remember what I said about 34. B and D are both the same. Now we look for it. So you either try to do it yourself or you try to process elimination. You have two logarithms that are being subtracted from each other. So the rules of logarithms, you got to remember, we put subtraction back together with division. So we have lots of division all over the place. All of these have some kind of division. But this one is a logarithm over a logarithm. That's the change of base rule. When you have one logarithm base m over one logarithm base m, that's when you have a change of base rule. We took another logarithm and split it up into two logarithms over each other. Change of base rule. So you don't have logarithm over logarithm. You have one logarithm of y over q. Put it back together with that. But 8 goes up because you can't do it until you couldn't move back into the same apartment unless you packed your bags before you moved in. So the 8's got to go up and the 2 would go up. If the 8's got to go back up before you can put these two back together, would it be times the 1? 8 times 1? No. That 8 goes back up. That's the come on down property, that power rule. It wouldn't be back in times the 8 or times the y. It would be y to the 8. Even these three have y to the 8. This is 8 times y. That is what. Okay. And these, obviously, they're the same thing, they're probably the right answer. 8 goes up here, and that's the first term, that would be the numerator. This 2 goes up here, so if the 2 goes up, back up here, you're going to end up with q squared squared. Power to a power, you multiply 2 times 2, you would get log base m of q to the 4th power. And because that's the one that's being subtracted, when you put it back together with this, log base m of y to the 8th minus log base m of q to the 4th, these two go back together as one logarithm, base m of y to the 8th over q to the 4th. So that process of elimination, no way, and that 8 times the y doesn't look like it. So the only ones that have a chance would be these two, which are the same thing, so that's it. Okay. And since we're here, let's look at 33. So 33, again, I don't have control over that test generator's function, but this is log base 3 of q plus log base 3 of r. If you have separation with addition and wanted to put it back together as a single logarithm, is it just multiply the two logarithms together? That doesn't seem right. Do you put, if you have two logarithms added together, do you just put it back together with, let's just make an addition of the q and r? It doesn't look like I would separate this instead of just the adding of the two logarithms, because that's where you would go. Well, fractions mean subtraction. Log base 3 of multiplication. That looks right. You separate multiplication with addition. The other ones don't seem like we've done anything close to them. And maybe you look at some of the other questions, and that will jog your memory. And since we're here, 32. So let's take care of 32. So we have division, so we should have subtraction. Well, there's 2 with subtraction. A has subtraction, and C has subtraction. D is addition, so that's not it. This one is divide the top, divide the bottom. That's not how you separate division. We use subtraction to separate division. So that's not it either. So here, it's 1/2 log base 4 to the 5. And here we put a square root around the whole logarithm. Are we taking the square root of the whole logarithm? No. Then where's the 1/2 coming from? A square root of 5 is 5 to the 1/2 power. This is log base 4 of square root 5 minus log base 4 of 6. And you need to recognize that this is log base 4 of 5 to the 1/2 minus log base 4 of 6. And the 1/2 comes down in front, 1/2 log base 4 of 5. That's where the 1/2 comes from. Square roots are 1/2 powers. Cube roots are 1/3 power. Fourth roots are 1/4 power. Or you're not good because we're using the same information. Oh, actually, I'm not sure, we can use the same information. Sometimes I wonder, I think I want to do um, the long and drawn out way. But I'll always get the person that goes, well, couldn't you just? And then so it's, all right, I guess I'll just go ahead and do that first. And then I'll do the long and drawn out way. So I'm gonna go ahead and do the long or the short way quick. Well, natural log of e to the x minus natural log of e to the fourth equals natural log of e to the fifth. Well, we're taking natural log of e to the somethings. The base of a natural logarithm is an e. And inside, if you have a base e of an exponential function, an exponent base e of x, then the bases are the same, they just undo each other, you get whatever the power is. So the natural log of e to the x, that's just x, minus the natural log of e to the fourth, well, that's just a 4, equals natural log of e to the fifth, and that's just a 5, add 4, and we get x equals 9. Because the base of the natural log is e, and inside that logarithm is a base e, so they undo each other. Or you can put subtraction back together with division. So you can make one logarithm, and that would be e to the x in the numerator over e to the fourth in the denominator, and that would equal natural log of e to the fifth. And then technically it's this rule. If you have natural log of this, x equals natural log of that y, natural log of x equals natural log of y. If you have two natural logs equal to each other, then the inside, the x has to equal the y. So natural log of this equals natural log of that, then e to the x over e to the fourth has to equal e to the fifth. And since this is division, I'm going to multiply both sides by e to the fourth. So e to the x is equal to, when you multiply, you add the powers. This is e to the ninth. And since we have the same base, x has to equal 9. But it's also based on, do you recognize that they're both, the bases are the same? Natural log is base. Inside, it's a base e. Merry Christmas. Because if you recognize it, you're done. And that's the whole point of it, recognizing that it's there. A lot of people won't. They'll stare at it and hoping that staring will cause it to do itself. Like I'm going to win a staring contest with a math problem. Usually doesn't happen. But it, it's 5. That's not multiplication. That's log base 5 of log base 5 of x equals 1. Look at this. This is log base 5 of log base 5 of x, and it's equal to 1. Composite function. Log base 5, this one is go from left to right. Log base 5 of this equals 1. So convert it. Base to the across equals what's inside. What's the base, as you read from left to right, what's the base of that logarithm? So base to the across equals what's inside. Base 5 to the first, so 5 to the first. This 5 to that first is going to equal what's inside, which is log base 5 of that x. Base 5 to the across equals what's inside. And what's 5 to the first? 5. So this is now just 5 equals, I'm just writing it again so you see. Because then you just do it again. Do it one more time. So you want x base to the across equal that inside. So this base 5 to that across equals what's inside that x. 5 to the 5th is 3,125. So it's just unraveling a composite function. Yeah, no, I have it twice. I mean, now you go 5 to the 0 equals this, and 5 to the 0 is 1. So then this equals 1, that would start the whole thing. You still get 3,125. Again? 19? 14. Okay, so that one we're good. Now we're looking at that, possible bonus line. So square root 2 to the x plus 1 equals 40x. So you have an exponential equation, which means you got to get the same base on both sides. Either that or you're using logarithms. You can't really use logarithms until you simplify both sides. Radicals. You don't get the same base when you have a radical, so you have to convert the radical into an exponent. And I erased what I've already written up here, but it's this. Rule 9. A to the 1 over n is the nth root of a. That's a square root. A square root is a 1/2 power. So this is 2 to the 1/2 to the x plus 1 equals 4 to the x. So what we have is, on the left side, 2 to the power you multiply. So don't forget, it would be distribution because there's two terms. So it would be 1/2 parentheses x plus 1, 1/2 to the x, no, 1/2 times the x plus 1. And then you have to get the same base. So can I write 2 as a power of a 4, or can I change 4 and make it a power of a 2? 4 is what as a 2?
It's power two.
It's a 2 squared. This is 2 squared to the x. So over here, it's just 2 to the 2x. On the left, you have a square root 2. It's not going to be anything but a base 2. On the right, you have a 4. I can change 4 into 2 as a 2 squared. So now they're both base 2. Over here, it's now 2 to the 1/2 times x plus 1. Over here, 2 to the 2x. So since you have the same base, they're both base 2 on this side, 2 on that side. Then this exponent, 1/2 times x plus 1, it has to equal this exponent, just the 2x. So now you got to make a choice. First of all, make sure you have the print. You either undo the fraction or you distribute, which means you're going to have 1/2 of x plus 1/2. You're going to have fractions and then undo the fraction. So let's undo the fraction right now. How many total terms do you have on this left side? How many terms? We have one thing. We have this term. Okay? So you're only going to need to multiply this side by 2. Don't multiply everything by 2 because you haven't distributed yet. You want to undo this denominator because you're just going to multiply this side by 2, and you're going to multiply this side by 2 because it's going to reduce that 2 before you distribute. So you just have x plus 1. And over there, now you have 4x. No more fraction. Something we've been talking about since that first fraction. So should we subtract 4x on over here to the left and then subtract 1 over to the right and then try to solve? Or should we subtract 1x and then divide by 3? Subtract x from both sides. So 1 equals 4x minus x is 3x. Then divide both sides by 3. X is equal to 1/3. That's why it's bonus level, because you have to convert that square root into a half. Well, you guys are done? No questions? More questions? Or you're gonna leave, it's fine. Okay. Not gonna like throw anything at you. I'm not gonna throw anything and hit you, but Like to throw something towards you. For anybody else who's staying west. But you guys are ready to go off campus for lunch, you're gonna get a crowd up there. Another party lot. You gotta wait till I'm done answering these questions. So synthetic division, the good news is all the terms are there, x to the second, x to the first, x to the one, x to the zero, and it's a binomial. So let's just go ahead and go from here. If x minus the k, so what does k actually equal? Positive one. So we're gonna put one in the box. The coefficients of the dividend, 3, -8, and a 5. And what we do is we bring down the first coefficient. Draw that line. We bring down the 3, straight on down, and then we multiply, then add. So 3 times the 1, we get 3, and then we add. -8 plus 3 is -5. Then we multiply. -5 times 1 is -5, and then we add, and that's a 0. So there's no remainder. It was x to the second. It was 3x squared minus 8x plus 5. So since we were dividing x squared by x to the first, the quotient's going to start with x to the first. 3x minus 5. Yeah, minus 8. Okay. So now e to the 2.1. So we've used the natural line button. The e to the x button is the second function right above it. One e to the 2.1 power. So right here, right above the natural line button is e to the x. So to activate that blue function, you gotta press the second key and then hit this key. So second, and then natural log button on the screen that e to the 2.1. So parentheses, and then we hit enter. And we round it to 3 decimal places. So 8.166. There's some crazy things happening. I don't know if it was the wrong buttons, pressing logarithm instead of e to the button. I know some people thought it was 5 times 2 or -5 times 2 instead of. So, yeah, so ask, if you're not sure, ask.
Okay.
And that's, yeah, I wouldn't have written up another piece that you have to figure out before you actually do the problem. So always ask. Like on number 10, it's e to the -2.7. Just make sure you ask. Like number 8 is 2 to the pi. So you don't want to just punch up your own 3.14. So 2 is the base, and then your exponent button is here, and then the pi button is in blue right here where your exponent button is. There's pi.
So we have to hit second. And then that pi button, so 2 to the pi is 8.2. That's how you get it. And you know what? I don't know what I was thinking. We get out at 10 till. What am I thinking? I thought we got it at noon for some reason today on the whole things. My bad. I mean, it's still doing it. I'm so sorry. I'm so sorry for the internet.
You have to get extra.
Well, that's fine too, but for some reason I'm going,